Section 3.2, Leveraging Pre-trained Models for Vision and Language Tasks. Lesson 3.2.1 Transfer Learning, Reusing Learned Features. All right, let's dive in. Have you ever wondered how some machine learning models seem to work so well, even when they're applied to completely new problems? Well, the secret often lies in something called transfer learning. It's a powerful concept that allows us to reuse knowledge from one task to solve another. Let me explain. Imagine this. You've spent years learning how to ride a bike. Now, someone asks you to learn how to ride a motorcycle. Would you start from scratch? Probably not. You'd use what you already know about balance, steering, and acceleration to make the transition easier. That's exactly what transfer learning does for machine learning models. So, what is transfer learning, really? At its core, it's about taking a model that's already been trained on a large dataset, say, millions of images or sentences, and adapting it to solve a new, related problem. The beauty of this approach is that it saves time, computational resources, and often leads to better performance than training a model from scratch. Now, let me emphasize this. The key idea here is reusing learned features. Think about it for a moment. When a model is trained on a massive dataset, it learns to recognize patterns like edges, textures, or even more abstract concepts like shapes and objects. These features are incredibly valuable because they can be reused for other tasks without needing to retrain everything from the ground up. This brings us to our next point, leveraging pre-trained models as feature extractors. Picture a pre-trained model as a highly skilled assistant who's already done most of the heavy lifting. Instead of starting over, you can plug this assistant into your workflow and focus on fine-tuning their skills for your specific needs. For example, if you're working on a computer vision task, you might use a pre-trained model to extract features from images and then train a smaller model on top of those features. This approach works wonders, especially when you don't have a ton of labeled data. Speaking of fine-tuning, let's talk about strategies for freezing and fine-tuning layers. When you're using a pre-trained model, you have two main options. You can either freeze some of the layers, meaning you lock them in place and don't update their weights, or you can fine-tune them by allowing their weights to change during training. Freezing is great when you want to preserve the general knowledge the model has already learned, while fine-tuning lets you adapt the model to your specific task. The choice depends on your data and the problem you're solving. Finally, let's touch on applications. Transfer learning isn't just limited to one domain, it's everywhere. In computer vision, it's used for tasks like image classification, object detection, and even generating art. In natural language processing, or NLP, it powers things like chatbots, sentiment analysis, and question answering systems. Pretty cool, right? Recap point. Let's recap what we've covered so far. Transfer learning allows us to reuse knowledge from pre-trained models, saving time and resources. We can leverage these models as feature extractors, and we have strategies like freezing and fine-tuning to adapt them to new tasks. And of course, transfer learning has tons of applications in both vision and language tasks. Now that we've laid the groundwork, let's move on to the next lesson, where we'll explore pre-trained models specifically for computer vision. Lesson 3.2.2, Pre-trained models for computer vision. Now that we understand the basics of transfer learning, let's zoom in, pun intended, on pre-trained models for computer vision. These models are like the superheroes of the machine learning world, and today we'll meet some of the most famous ones. First up, we have architectures like VGG, ResNet, and Inception. These are deep convolutional neural networks, or CNNs, that have been trained on massive datasets like ImageNet, which contains millions of labeled images. Each of these architectures has its own strengths. For example, VGG is known for its simplicity and depth. ResNet introduced the concept of skip connections to handle very deep networks, and Inception uses clever tricks to make computations more efficient. Think of them as different tools in your toolbox. You pick the one that best fits your task. But how do we actually use these models? One common application is object detection and segmentation. Imagine you're building a system to identify cars in traffic footage. A pre-trained model can help you detect where each car is in the frame and even segment out its exact boundaries. This is incredibly useful for applications like autonomous driving or surveillance. Now, what if your task is a bit more niche? Maybe you're working on recognizing rare bird species or classifying medical images. That's where adapting pre-trained models comes in. You can take a model trained on general images and fine-tune it on your specific dataset. This way, the model learns to recognize the unique features of your domain while still benefiting from the general knowledge it already has. Here's a question for you. How do you know which pre-trained model to choose? Well, benchmarking is your friend. Researchers and practitioners often compare models based on metrics like accuracy, speed, and memory usage. For example, ResNet might perform slightly better than VGG on certain tasks, but it could also be faster and more efficient. It's all about finding the right balance for your specific needs. To summarize, we've explored popular pre-trained CNN architectures like VGG, ResNet, and Inception. We've seen how they can be used for tasks like object detection and segmentation, and we've discussed how to adapt them for novel recognition tasks. Benchmarking helps us choose the best model for the job. All right, now that we've covered computer vision, let's switch gears and talk about pre-trained models for natural language processing, or NLP. Ready? Let's go. Lesson 323. Pre-trained models for natural language processing. Welcome back. If computer vision is about teaching machines to see, then NLP is about teaching them to read, write, and understand language. And just like in vision, pre-trained models play a huge role here. Let's start with word embeddings. Have you ever thought about how computers represent words? Traditionally, words were treated as discrete symbols, but that approach doesn't capture the relationships between them. Enter word embeddings, a way to represent words as dense vectors in a high-dimensional space. Words with similar meanings end up close to each other in this space. For example, king and queen would be neighbors, while king and apple would be far apart. This is crucial to understand, because it forms the foundation of many modern NLP models. Now let's talk about pre-trained language models. These are the of NLP, models like BERT, GPT, and what makes them special is that they're trained on massive amounts of text data, learning to predict missing words, generate sentences, or even answer questions. Think of them as incredibly knowledgeable assistants who read almost everything on the internet. So how do we use these models? One common approach is fine-tuning. Let's say you're building a system to classify customer reviews as positive or negative. You can take a pre-trained model like BERT, feed it your labeled data, and fine-tune it for your specific task. The result? A highly accurate model with minimal effort. But there are a few considerations to keep in mind. First, how you break text into smaller units like words can affect performance. Second, sequence length matters. Most models have a maximum input length, so you'll need to decide how to handle longer texts. Finally, fine-tuning strategies vary depending on your task. Sometimes, you only need to train a few layers. Other times, you might want to update the entire model. Let me emphasize this. Fine-tuning is both an art and a science. You'll need to experiment to find the right balance between preserving the model's general knowledge and adapting it to your specific task. To recap, we've discussed word embeddings as a way to represent text, explored pre-trained language models like BERT and GPT, and talked about fine-tuning strategies for tasks like text classification and question answering. Sequence length and fine-tuning are all important factors to consider. All right, we're almost there. Let's wrap up this section by talking about model hubs and repositories, where you can find and share pre-trained models. Lesson 324, Model Hubs and Repositories. Welcome to the final lesson. By now, you've probably realized that pre-trained models are incredibly valuable. But where do you find them? And how do you choose the right one for your project? That's where Model Hubs and Repositories come in. Platforms like TensorFlow Hub and Torch Hub are like libraries for machine learning models. They host a wide variety of pre-trained models for vision, language, audio, and more. Whether you're looking for a model to classify images, generate text, or transcribe speech, chances are you'll find something that fits your needs. But with so many options, how do you decide? Here are some guidelines. First, consider your task requirements. Are you working on a vision task, an NLP task, or something else entirely? Next, think about resource constraints. Some models are lightweight and fast, while others are larger and more computationally expensive. Finally, look at the documentation and community support. A well-documented model with active contributors is always a safer bet. Have you ever thought about versioning? Just like software, models evolve over time. Best practices include keeping track of which version of a model you're using and documenting any changes you make. Attribution is also important. Always give credit to the original creators when you use their work. Recap point. Let's recap. Model hubs like TensorFlow Hub and Torch Hub are treasure troves of pre-trained models. To choose the right one, consider your task, resources, and documentation. Versioning and attribution are key best practices to follow. Closing segment. And there you have it. We've covered transfer learning, pre-trained models for vision and language, and how to find and use them effectively. I hope this gives you a solid foundation to start exploring these powerful tools. Remember, the world of machine learning is vast, but with pre-trained models, you don't have to start from scratch. Keep experimenting, keep learning, and most importantly, have fun with it. Thank you for joining me on this journey. Until next time, happy learning.